The ocean covers something like 70% of our planet. It's this massive, incredible system that pretty much shapes our entire world. But right now, there's a huge change happening, kind of quietly, under the surface. The ocean is getting warmer. So in this explainer, we're going to dive in and figure out what that really means, how it's happening, and why this warming that's hidden from view has some very, very visible consequences for all of us.
To really get our heads around this, we're going to break it all down. First up, we'll get a super clear definition of ocean warming. Then, we'll explore this amazing idea of the ocean as a great heat sponge. After that, we'll look at why this is such a slow, steady change. And finally, we'll connect all the dots to see why it actually matters in our day-to-day lives. Let's get started. All right, first things first. When you hear scientists or the news talk about ocean warming, what are they actually talking about? Let's pin down a definition.
Now, it might sound super obvious, right? But getting this definition right is the foundation for everything else we're going to talk about. This isn't just about a nice warm day at the beach. It's a very specific, long-term thing that scientists are observing. So, what is it really?
Okay, so here it is, plain and simple. Ocean warming is the long-term increase in the average temperature of the ocean's water. The key word there is average. We're not talking about daily changes or what season it is. This is a persistent, global trend that's been measured over decades. It's kind of like the planet's thermostat is just slowly but surely being turned up.
And here's why that's such a big deal. You might think, come on, a single degree? What difference does that make? Well, in a system as gigantic and complex as the ocean, a small increase in the average temperature pumps a massive amount of extra energy into the water, and that leads to these huge cascading effects all over the globe. So you're probably wondering, how is all this extra heat getting into the ocean to begin with? Well, that brings us to one of the ocean's most incredible and important roles in our climate. It basically acts like the planet's great heat sponge. So oceans are naturally amazing at soaking up energy from the sun. That's just what they do, and it helps keep our planet stable. But here's the kicker. Now, they're also soaking up all the extra heat that's being trapped by greenhouse gases in our atmosphere. So the real question is, just how much of that extra heat are we talking about?
The number is just staggering. It's over 90%. I mean, just let that sink in for a second. Of all the excess heat that our atmosphere is trapping, more than 90% of it ends up in the oceans. To give you some perspective, that's like the energy of several atomic bombs going off in the ocean every single second. Without the ocean absorbing all that, the air temperatures we experience on land would be unbelievably higher.
So how does this actually work? Well, it's a pretty clear two-step process. First, as we get more greenhouse gases in the atmosphere, they act like a thicker blanket, trapping more of the sun's heat. And then, step two, that extra trapped heat in the air gets transferred directly into the ocean. It's a really simple exchange, but it has these massive consequences. Okay, and this brings up a really, really important point. Water and land are completely different when it comes to heat, and understanding this difference is the key to seeing why ocean warming is such a long-term problem. This comparison makes it super clear. Just think about black pavement on a hot summer day. It gets scorching hot really fast, but as soon as the sun goes down, it cools off quickly. The ocean? It's the exact opposite. It takes a ton of energy to raise its temperature even a little bit, but once that heat is in there, the ocean holds onto it for a very, very long time. And this is what makes ocean warming so tricky. We don't notice these tiny, tiny changes from one day to the next. It's not obvious. But over decades, that slow, steady accumulation adds up to a colossal amount of trapped energy being stored away in our oceans. And that energy, it has to go somewhere. So we've covered the what and the how. But that brings us to the biggest question of all. So what? Why should we care if the ocean is a tiny fraction of a degree warmer? Let's get into the real-world impacts.
The effects are they're huge, and they're all connected. You've got devastating coral bleaching, which basically starves these incredible underwater ecosystems. A warmer ocean can mess with major currents that drive weather all around the world. Of course, it puts huge stress on marine animals. But one of the most direct and dangerous impacts for us on land has everything to do with storms.
Honestly, the best way to think about it is this. Warm water is literally storm fuel. Hurricanes, typhoons, cyclones, they all draw their raw power from the heat sitting in the top layer of the ocean. So the more heat there is, the more fuel is available. And that extra energy can supercharge these storms, making them way stronger, way wetter, and a whole lot more destructive.
And so that brings us to the final thought I want to leave you with. For decades, the ocean has been like our planet's silent protector, right? It's been absorbing almost all the extra heat we've been producing, shielding us from the worst of it. But that sponge?
Well, it has a limit. And the critical question for all of our futures is, what happens when the planet's great heat sponge is finally full?